For problems that you need to factor by grouping, there may not even be a squared term. What you're really looking for are common factors. And for the beginning part of these problems, the common factors are going to be in parentheses. If you look at this polynomial right here, you notice that there are two terms here, this one and this one. These two terms both have a common factor, that is r minus s. So we're going to factor out r minus s and put it in front. What do we have left over after we factor out r minus s? Remember, when we factor out, it's just like we divide by r minus s. If we divide by r minus s, these cancel, and I'm left with 7, plus these cancel, and I'm left with t. This is another factor by grouping problem. Again, we want to factor. So while some people might think, let's distribute here, we actually want to leave them inside of parentheses. Why? Well, look at what's inside the parentheses. A minus b, a minus b, a minus b. They all have the factor of a minus b in common. So we're going to factor that out. We put it out in front. If that's in front, what is left over? A plus 4b minus 7. It was like I divided each of these terms by a minus b. What is left over were just the numbers in front. This polynomial has two terms. What factor does it have in common? X minus y. That goes out in front. What is left over when you take out the x minus y? The w minus 8. This is the factored form. When we try to factor a polynomial by grouping, what we really mean to do is take two terms and group them together. It's like they're written here in parentheses. And these two terms group together as they're written here in parentheses. Now usually, in order to factor by grouping, what is inside of both parentheses needs to be exactly the same. Right now we don't have that, but we can make it the same by factoring out each set of parentheses individually. So first we're going to factor this one, then we're going to factor this one. What is the greatest common monomial factor in these two terms? 3p. I'm left with p. Oh, that is wrong. I'm left with 3 minus q. These two. What is your common factor? They're both divisible by 2 and they both have an n. Plus 2n goes out in front. Right here is left with 3 minus q. All I did was factor each individual set of parentheses. Now, to factor by grouping, I have the same factor in each parenthesis. That factor can go out in front. What is left over? 3p plus 2n. In order to factor by grouping, we are looking at a polynomial whose terms are grouped using parentheses, and that what is left over in parentheses is exactly the same. Right now, these two terms almost have the same factor, except for the subtraction here is opposite than the subtraction here. We can't go ahead and put out a factor in front and see what's left over like we have been doing. because they don't have the same factor in common. But what we can use is the fact that these two terms are opposites of each other. If you notice, here A is positive and here A is negative. Here 3 is negative and here 3 is positive. So they're opposites. In other words, I could take this factor and rewrite it as the opposite of A minus 3. I'm basically factoring out a negative. I'm switching around the order of subtraction and factoring out a negative. And these two are really equivalent because if you look and distribute back the negative sign, I'm going to have negative A, which is up here, and I'm going to have a negative times a negative, which makes a positive 3, which is also up here. So I'm going to replace this factor in this problem with negative A minus 3. In order to do that, I'm putting the negative out in front, and I'm going to put it in front of all of these terms. So negative 2A, and now this factor becomes A minus 3. This factor stays exactly the same. I have done nothing over there. Let me get rid of this stuff. So, is this something I can factor by grouping? You bet. A minus 3 is the factor they have in common out in front. What is left over if I take away the A minus 3's? 5 minus 2A. That is the factored form.